What do you think of when you hear the word vault? Hey, in the back of the room there? Not you. I don't mean safe cracking and thermite. It's kind of reassuring, isn't it? Like a nice, safe, secure place where everything will be okay. I mean, unless you're a professional jewel thief or something, like that dude in the back. Sometimes it really feels like our design projects need a vault. When we have a project crunch, things tend to get messy and out of control. We end up wasting a lot of work and having to reinvent things that seem like we've already designed before. What we need is a safe, secure environment and process where things are nicely organized and well protected. We need that process to be easy to manage, so we don't spend all our time on the process itself. And we need that process to maximize design reuse, so we aren't always wasting time redoing work we've done before. A little like a vault for our whole design project. Hi, I'm Amelia Dalton, host of Chalk Talk. This week, I'm talking with Ben Jordan of Altium about how to set up a robust design for reuse design methodology for your team that will flow nicely with your project, won't take much effort to set up, and will bring big-time long-term benefits of design reuse, configuration management, and manufacturing handoff. Guess what it's called? Before we get started, I want to remind everyone that you can click on that Download Now button below your player. There you can download a free white paper that further expands on this topic. Thank you so much for joining me today, Ben.
Thanks for having me.
So Ben, we're going to talk about vault-driven electronics design. I honestly don't know what that is. And what do you picture when you read vault-driven electronics design?
It's a good question. So when I picture vault-driven electronics design, it's kind of funny because actually in my head I picture a little picture of a vault driving a car down the road. But
okay.
Anyone who follows Altium would know that Altium Designer is our main product, which is for electronics product development.
Mm-hmm.
So that does all your schematic design, your PCB design, FPGA, embedded,
Right.
etc. So that's really an ECAD design tool, for want of a better term.
Mm-hmm.
And we also have a software product called the Vault Server, and this is actually a data management server for storing design data in and managing its life cycle and things like that. But the important thing is you can provide all the great tools in the world, but it doesn't necessarily do you any good unless you also have a methodology to go along with it.
Very true.
Vault-driven electronics design is a complete methodology surrounding the tools.
Okay, Ben, with this logo here, I see a board with a bunch of little modules on it. Tell me what this is. It looks pretty cool.
It is pretty cool. That's actually a new splash screen for our main product, Altium Designer.
Okay.
I guess we're kind of tipping our cards a little bit in a way. We're currently developing a series of little electronics modules with our own internal hardware development team. And the purpose behind that is really to take design reuse to the next level. We kind of figured that a lot of design functions, a lot of features of products are really commoditized to the point where you shouldn't have to redesign a Wi-Fi interface
Absolutely.
or a Zigbee interface if that's something that you need in your design.
Mm-hmm.
So we're actually setting about designing a lot of those things and validating them and working out the manufacturing bugs and all of that. And this is kind of a sneak peek at what we've been doing there.
How cool. So give me a little bit of history. How did Altium evolve to this point?
We've been talking about electronics design and data management related concepts for a long time. I mean, as far back as Protel 99 SE, back when we were known as Protel, we introduced what we now call the unified concept, where you have a single database and one design platform that is basically one executable that gives you all your schematic, your PCB design capabilities, your library management, and this concept of one component and one netlist in memory while you're working on the design. With that comes a lot of efficiency improvements. It sure beats having two different design tools by two different vendors and having to shuffle netlists between them.
Mm-hmm. Absolutely.
But we keep going on from there, and we completed that platform in 2002 with the DXP release, and we also introduced around that time the ability to link to corporate databases for component information to streamline the process of purchasing and bill of materials management and that kind of thing. Following on from there, in 2004, we introduced our FPGA and embedded design capability, but along with that, we also brought in support for version control systems, which was a real landmark achievement for hardware developers who could now compare different revisions of a printed circuit board graphically to see what's actually changed. So all along the way, we've continued to bring in these new capabilities to try and improve the data management process. And of course, fast forwarding up to the most recent release, Altium Designer 10, and subsequent updates to that, where we introduced a really good formal release process where you can atomically generate a release and store it in an Altium Vault, which was another technology we released in 2010, for properly lifecycle managing your design data and also going through that process of making sure your outputs are consistent and validated and really ready for release to manufacturing.
So just because you released a technology doesn't mean people wake up and immediately start using vault-driven design, right?
Absolutely. You know, like with anything new, most of us just kind of stand around waiting for someone else to try it first.
True.
Because we actually have our own electronics design team, we don't just make electronics design software. And I think this is a pretty unique thing for us. We use it too. And so we kind of have an advantage that we, as I like to put it sometimes, eat our own dog food.
True.
We use our own software to design our own electronics hardware. And along with that, we also get the advantage of feedback from all of our users. We have a huge number of users worldwide, and they're very active on our forums and active with our development teams giving us feedback.
That's great. So we've said that you guys are doing a lot of designs. What kind of designs have you done?
That's another good question. It really started back when we brought in Nexar 2004 and the FPGA and embedded design capability. We wanted a really good FPGA prototyping platform to go along with that. So we released the Nanoboard NB1, which was our first publicly released FPGA development board. And that was great because we wanted to make that a modular, vendor-neutral design. And that meant we had to overcome a lot of design challenges that other tools at the time didn't seem to overcome, with being able to easily reconstrain designs and retarget to different FPGA families. And that led us to really understand well what it means to have good configuration management. And following on from there, we developed a newer version for release with 2008, which was the Nanoboard 2. Again, a modular design where you could change different FPGAs and different daughter cards for different capability. And what we learnt with the Nanoboard 2 was that we could design something really effectively and really quickly from a hardware standpoint. But then it was quite expensive. We actually couldn't sell them for less than about $2,000 each.
Yeah.
And while that was still pretty good price for the capabilities that you got at the time, most other equivalent FPGA design boards were twice the price.
Right.
But we felt we could do a lot better. And so that led us to the Nanoboard 3000, where we wanted to target something under $400.
Okay.
And that's quite an achievement when you consider there are two FPGAs on this device and a whole lot of SRAM and SDRAM and a TFT touchscreen. So this was our foray into data management from a cost engineering point of view.
Ah, okay.
And so that opened our eyes. What do we need to do to give our users the capability to cost engineer their designs? And that actually led to Altium Designer having the ability to link to different part vendor websites and online catalogs and actually search for their pricing and availability information live.
Wow.
That was introduced in the Summer '09 product, along with the release of the Nanoboard 3000.
So, Ben, people are always telling us a bunch of stuff we should do. We should exercise. We should floss. Why should we do vault-driven design?
Really, the main thing is you'll get exponential gain in efficiency and output quality over time, because a central theme in vault-driven electronics design is design for reuse. And that means whatever design decisions you make with reuse in mind. So if I have a typical let's say, a DC to DC regulator circuit that I want to use to power an FPGA or microprocessor, instead of just redesigning that each time I start a new design, I'm going to design it the first time thinking, what do I need to do to make this reusable across a plethora of designs?
Okay.
And as a result of that, I might make it more parameterized or more generic in nature. It also changes my approach to design from more of a flat style to a hierarchical approach. What that means then is we can use proven circuits over and over again. If I design this DC to DC regulator, as the example may be, I've done it once, I've tested it once, I've employed it in more than one product, and I know it's going to work. It's been truly validated. It also allows us to leverage the metadata of designs. So, for example, that life cycle state, the fact that it's been validated, we know when we're designing another product, we can choose different subcircuits to use in that product based on their life cycle status. This one's ready, for example, for prototype only. It hasn't yet progressed to a production ready status. There may be another circuit that does the same thing that's approved for production. So that can help the designers spend less time worrying about, can I get this part? Is this okay? And more time actually getting on with the design and doing their thing and being creative where they need to be creative.
Right. So we've talked about this methodology at a conceptual level. Can we dive down and see how it really works?
Absolutely. Really, in this approach, we have kind of two spaces. We have our work in progress space, which is where we use a version control system and where we have our actual design files. And this is a very fluid, dynamic place where the designer's working day to day, placing components on sheets, routing tracks on a printed circuit board, writing code for an FPGA or an embedded processor, and checking those changes, that day-to-day work in progress, into the version control system. And so at a hardware level, working with the vaults, what this means is we're going to start with a schematic symbol at the lowest level. And a schematic symbol will be something that is reduced to the most reusable element possible. For example, in our flow, we may have maybe 8 to 12 different diode symbols for all the different types of diodes that we will ever use. We only need to develop those symbols one time. And each time I want to use a new diode from a different manufacturer, I don't need to recreate that symbol because we also use naming conventions. And the naming convention makes it very easy for me to find that symbol in the vault and apply it to the new diode component that I want to create.
Makes sense.
Yeah. Likewise, we do the same thing with the PCB footprint. And fortunately, there are a number of standards out there like IPC and JEDEC, which also make that even easier. And also, we go by manufacturer data sheets. So each manufacturer has their own naming convention for a footprint. So for one manufacturer, there may be a set of maybe 50 different footprints that they would use across all of their semiconductors. So we only need to make those and make them once, and we can make any one of the thousands of components that a company like TI or Dallas or whoever would make. And those models, we call them, the symbols and footprints, are formally released into the vault, and those are then revision controlled. So if we need to make an update, we can re-release them to a new revision. And at that point, we create a unified component which combines the symbol and the footprint with the parametric data that makes that component unique. So that's data like a link to the manufacturer's website, to the data sheet, parameters such as tolerance, temperature, range, all of those things that define the unique aspects of that part. And those reference the models that were already released into the vault. At that point, we release the components, and those become also lifecycle managed items in the vault. And they will also have a part choice list which links them dynamically to the vendor information that I mentioned earlier. So pricing and availability data, which is always available as long as I have an internet connection.
Very cool.
From that point, I can create a sheet or a schematic page. And of course, on the sheet, you place components and then you wire them up. Now, there's a few important things about sheets in this methodology. First of all, we're going to design the sheets to be reusable as much as possible as well. So kind of as a rule, if there's going to be more than one component on the sheet, we'll make it like a hierarchical block with ports to connect out to other design sheets.
I see.
And those have a convention for net naming, for power and ground and so forth.
Okay.
And we make these strictly hierarchical.
Okay.
So in going back to my DC to DC converter example, I'm going to design that DC to DC converter regulator on one schematic page with its inputs and its outputs and probably some control signals to make it parameterized. And I'm going to release that as a managed sheet into the vault. Again, that managed sheet now has a lifecycle status and it has a revision number. And if I'm going to make some change to that or modify it, I will release a new revision, which has its own life cycle. Now, the cool thing about all this is the vault retains links between all of the parent and child items.
Oh, okay.
So every schematic sheet that I release to the vault contains a bunch of components wired up together in some configuration, and all of those components come from the vault, and you can browse to look at the actual individual details of each of those components, and for each of those components you can see where those are used, in what different sheets and what different designs. Once we have our sub-circuits designed as sheets, of course, the next step is to create a PCB project or a design. And we're going to release those and use them in the design as device sheets. So the PCB project is the next stage where we place our schematic design sources and managed sheets in the design and wire everything together and ultimately create a printed circuit board as well. And the important thing to note here is that in our methodology, these things all are driven by templates, which we'll get to in a little bit. From the PCB project, we then actually release a design, but we release different configurations. There are configurations for fabrication, for generating things like Gerber files or ODB++, drill drawings and things of that nature for actually fabricating the PCB. And we also have assembly outputs for actually stuffing the board with the components.
Okay.
And then the other side of it, which is very important, is validation. Validation basically means making sure your design passes all the design rule checks and is okay to go.
So, Ben, explain how this is different from traditional data management. Is this more than just checking your stuff into a repository?
Absolutely. This is actually kind of a natural evolution of typical design data management, and it builds on existing technology with standard, well-defined tool setup, a standard, well-defined process for using the tools and using version control and using the vaults, a discipline of reuse, the modular design concept, and an easy-to-do-it-right mentality. Basically, if you set the system up right, it makes it easy for designers in the team or even as an individual user to make the right choices up front. And in the end, it just makes things a lot more efficient and productive, and the quality of output goes up.
Yeah, that makes sense. So, what are the key elements of vault-driven design?
The first key element really is the design for reuse, which I've mentioned before. This concept basically means every choice you make as a designer is done with reuse in mind. So all the way from the lowest level element being a schematic symbol or a PCB footprint, you think, how can I make this as widely applicable as possible without losing its actual design intent?
Right.
And so to go back to the diode example I used before, there's probably, for most organizations, about 6 different diode symbols. We have, I think, 8 in our vault, which cover the different combinations. So, for example, there'd be your standard SI-PN diode. Then there'd be Schottky diode, which is a different symbol. Then there'd be Zener, there'd be Viracta, and a few others, maybe Tunnel. And then there's different multiple diode combinations, and these are all going to be different symbols. And you would build those, and this is very important, and release those into the vault with a specific naming convention, which makes them very easy to find. Because you're going to reuse them across multiple different components, it has to be easy to find them so that you can do that.
Right.
And then at the next level up, at the schematic level, you're going to build each schematic circuit to be reusable, and those are released into the vault as managed items. Those can then be shared amongst even different design teams. Within one company, you may have one vault and several different design groups accessing the same data. Basically, that's the main thing. So every part must first exist in the vault as well. This is another important for reuse concept, that a designer doesn't just create a new component that they need in a design and place it directly in the schematic. That there's a discipline on the team to say, if this thing doesn't exist in the vault already, we will create it and release it using the formal process, because yeah, it takes a little bit longer, not much longer.
Yeah.
But once it's there, and you don't have to do it again.
Right.
It's all about doing it once and doing it right.
Makes sense. So in a lot of people's methodology, design for reuse is an afterthought. But this approach is switching that around, right? This methodology is all about designing for reuse first. Am I right?
Absolutely. And every sub-circuit should be designed, if possible, as a parameterized, reusable element. Coupled with that, we use a strict hierarchy approach. And what that means is everything is connected through hierarchical port to wire connections. So, in other words, every design we do is a block diagram at the top level, and all the connections are done through sheet entries and ports down into sub-sheets. And this includes power and ground nets. And the reason for that is it doesn't matter what they're named locally in each sheet. At the end, there's no ambiguous connectivity going on. Everything is visible to the designer, so it's hard to get it wrong.
So tell me what Altium is doing with this design for reuse methodology in your own internal design work that we've talked about.
This is actually something that's really exciting that we talked about a little bit earlier. What our internal electronics design team are doing are building these little castellated boards, which are common circuit elements like regulators or RF modules or JTAG connectivity, all sorts of different cool little things. You can see there's also a design there with a Class D audio amp board that's really quite high powered in a tiny little stamp form factor.
Nice.
So there's some kind of impressive stuff those guys are working on there. And what this is doing is it's taking it to the next level of design reuse, because each of these little modules is a PCB design in its own right, and it goes through the formal release process. Each component on each of those modules is an item that's placed in the design from the vault, and then ultimately that production data is generated through the vault release process for those modules. But those then, because they're modules, actually become components for higher level designs. So we're taking this to the next level of abstraction. From each of those modules, we actually create a footprint and a schematic symbol representing that specific module as a component.
Oh, okay.
So you can build other bigger designs made up of multiple modules very rapidly. That's the idea.
Very cool. Okay, so typically when we get ready to send a design off to manufacturing, there is a bunch of confusion as we are all trying to get the right specs to the right people at the right time. And then we have to do it all over again with our next design.
Yeah, that's actually traditionally a real cause of pain for every design house. And more with all the offshore manufacturing that goes on and working with third-party EMS providers, it becomes a big headache. And of course, using the vaults and using version control is all well and good, but if at the end of the day you're still just emailing the Gerber files and the drill files off to the manufacturer, there's no telling whether they actually are using the right versions.
Right.
So there's still a big hole in the process if you're not including your service providers in this methodology. For us, we're actually setting up specific areas in the vault which those manufacturers and assembly houses that we use can have access to. And when we release designs into those areas, they can see that they've been released, that there's a new version. There's no ambiguity at all in the system. They know exactly which one to use. There's no trawling through email trails or any of that stuff to try and figure out, do you have the latest version? Are you looking at the file timestamps and all of that to see if you're using the right Gerber files? All of those doubts go out the window. Using the vaults the right way, this is actually a possibility to give trusted third-party service providers access just to the data you want them to have access to.
Okay, so show us, Ben, what this looks like in Altium Designer.
Sure. In this methodology, in Altium Designer, what we have is a standard set of configurations. And to make this really easy for the designers to get it right, we've actually templatized the project. So all of the different schematics that they would use are drawn from the same source templates. And we also have those manufacturing instructions that you mentioned for generating the Gerbers to the right decimal places and the right format and all of those different things. Those can be standardized in Altium into what's called output job files.
Okay.
And one of the things that many of our existing users may not know is that output job files can be linked to multiple different projects to automatically reuse those instructions for generating the fabrication outputs.
Okay.
So what we do is we create a standard set of output jobs for fabrication, for assembly, and for documentation. So that can include things like PDF outputs, videos of the board in 3D.
Sure.
All of those things can be driven through these. And we have a standard set of those that are linked to all different projects, and that's set up as a project template. So each time one of our designers starts a new design, they automatically get the right output generators without having to think about it. And all of this is managed in version control on a day-to-day basis. So if someone needs to make a change, everyone else on the team knows about it because it's changed in version control. In our process, all of our projects start with the same project template, which has a default configuration set up with 3 configurations, one for fabrication, one for assembly, and one is a complete configuration that runs all of the output generators and creates a snapshot in time of the actual source files of the design. So that's a kind of posterity archive. Each of those configurations releases to a unique target item in the vault, which has its own revision and lifecycle status.
Okay, Ben, you mentioned templates a couple times. I'm not completely sure what you mean. Can you explain more about what templates are?
Sure. Every design begins with a standard template, which includes project settings, output generators and configurations, which I mentioned before, but it also includes some useful graphical info like title blocks and text on your schematic pages and your PCB document. This also includes things like form factors for modules. So in our case, we have a few different templates for different layer counts of board because we work with 4 or 5 different standard layer counts like 2 layer, 4 layer, 6, 8, 12. And so for each one, there are different requirements and tolerances for different things. And so those are all templatized. We also have the different form factors for the modules that we design. And for each different template, there are different design rules for making the actual boards. An important thing to realize here is that design rules can actually affect the fabrication output of the design too. Those are things like solder mask expansion, for example. If you change the rule, it actually changes what's generated in the output. So it's important to realize that, and that's why it's part of a template. The templates also include manufacturing and panelization data for the boards. The important thing to remember about templates is they're set up as part of the Altium environment. So once Altium Design has been set up with the different templates and you've got them all configured, anyone on the design team can start a new design and it'll automatically use a template. This is cool because it also prevents users from circumventing the process.
Ah, okay. All right, Ben, this sounds great. And if we want to get started with this methodology, what are the steps to get rolling?
Well, it's actually pretty straightforward.
Okay.
First, you need a Vault server, and you can set that up inside your company firewall. And you need a Subversion server. A lot of our users are already using Subversion. A lot of companies are using it for their software development. It's not a great stretch to add a repository for the hardware team too.
Sure.
It's open source and you can download it for free, so there's no reason not to use it. And of course, the other important piece for setting up is Altium Designer. We can set up Altium Designer preferences to point to your version control source repository for your work in progress design, and we can also configure it to point to the Vault. Another important aspect to make this methodology work for you is to develop a meaningful folder structure in the Vault that categorizes things like components, and you can see here in our Vault implementation, we've got them categorized by manufacturer and then by family.
Okay.
And within there, we've also got folders for that manufacturer's schematic symbols that we use for them and for the footprints that we use for them. Some schematic symbols that are in a higher level folder because they're generic and reusable, like the diodes I mentioned before, and you can see those here. Another really important thing, though, is when you're setting up your version control repository that you replicate that same folder structure and namings of all your different folders in Subversion. Because that means if you need to check out the source for something to make a change and release a new revision of it, it's very easy to find it. And that's basically where you get started.
Okay, Ben, where do I go for more information?
That's a really important thing because this really is a very high-level overview of how to do all of this. We've actually got a bunch of videos that walk you through the entire process, and basically, if you want, you can watch them all in sequence and follow the advice presented in each video and set things up exactly how we've done internally, and I can assure you that it will work well for you to do that.
Fantastic. I'm going to go check it out right now. Well, Ben, I think that's all I have time for today. Thank you so much for joining me.
Thanks for having me.
And before we go, don't forget to click that Download Now button below the player to download a free white paper that further expands on this topic. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.